go over what our second unit is all about, talk about how we're going to finish off with Unit 1. So if you look here in Unit 2 is basically all about linear relationships. You can see that the first concept is solving linear equations, inequalities. Functions are going to be linear functions, graphing, and writing linear equations as well. So if you wanted to like sum up Unit 2 in just like one word, you could just say linear, or lines, really is what it comes down to. And then I do want to let you know about what we're going to do with Unit 1. So we have our Simplify Algebraic Expressions concept quiz today, and that'll kind of wrap up Unit 1. But there is a Unit 1 test. If you looked ahead on the calendar, the Unit 1 test is roughly, I want to say like 10 to 12 days out, about 2 weeks out or so. So from here until then, all of your homework practice will continue to bring up all the old Unit 1 stuff. There is a kind of a practice test review assignment in the days leading up to the Unit 1 test. But we'll use these next couple of weeks here to kind of refine your skills and abilities with that. The DMR will support that as well as we get ready for that test. That make sense? Hope it does. All right, so let's go ahead and do our DMR. Let me get there too. Whoops. And there it be. 1, 2, 3, 4. Okay, so if you guys would, give it a shot.
It's definitely negative for that. Negative?
I doubt that. It's negative.
I love how confident you are. Let's see if it's right. So here we go. So number 1, said it 1,000 times. I'm going to say it again. In math, we do not read from left to right. We read according to PEMDAS. So I'm going to start with the innermost parentheses first. And I'm sure that you guys noticed that this was the inside parentheses, like all the way on the inside. 1 minus 3 times 4. So I think you guys are easily good enough to just do everything inside those parentheses first. So what is 1 minus 3 times 4? That's right. So it's going to be minus negative 11. And then that whole thing is squared. Okay, so then as I keep working in the parentheses there's still plenty to be done. It's 4 minus negative 2 squared, negative 3 squared. What is minus negative 11 really? Plus positive 11. Yep. And now I'm going to go ahead and do the exponents that I see. So it's 4 minus, what is negative 2 in the parentheses squared?
Positive 4.
Positive, right? Positive 4, yep. So 4 minus 4 times, now in here, what is the negative of 3 squared?
Negative 9.
That's negative 9.
That's where I went wrong.
Gotcha. That's an easy place to go wrong. Okay, so then finally, negative 9 plus 11 is 2. So let's see, I got this, and that's 2. I do that final exponent, so I end up with 4 minus 4 times 4. And then I do my multiplication. 4 minus 16. Did you get it?
Yes.
Negative 12.
Wait, how did you go wrong and get it right?
A lot going on there. Do you have any questions?
Oh my god. I'm so smart. You wouldn't have gotten that answer. You forgot the square, that's why.
Yeah, I forgot the squared, but I got the same.
You got the right answer, but did everything wrong.
And my math is correct.
All right. There's no questions. Kate, take a look at number 2. All right, I would do this according to order of operations, so I'd do the work in the parentheses first. 1/3 plus 11/12. Can I add those fractions the way they currently stand?
No.
Whoa, the common denominator issue. So for the 1/3, I need to multiply by 4 on the top and the bottom. So this would be 3/5 times 4/12 plus 11/12. So when I add fractions, like 11/12 plus 4/12, do I add the 12s and get 24?
No. You keep the same.
Keep the denominator the same.
What would be the point in changing the denominator to be the same?
I'm just asking.
No, exactly.
Yeah, that's a great question. That would kind of defeat the purpose. But you do add the numerators. 15 is 11 plus 4. And then when you guys got to this stage, did you guys do the little cross-canceling thing?
Yes.
I think it makes a lot of sense. So the 2 and the 12 would cancel to be a 1 and a 6, respectively.
Wait, there's no 2, it's a 3.
It's a 3.
Oh, it's a 3, you know. Sometimes you make mistakes and it has nothing to do with math. It has everything to do with reading. I somehow read that as a 2. It should be a 3. But you know what? We can still cross-cancel, can't we? Thanks for pointing that out. So let's see here. 3 and 12 cancel to be a 1 and a 4. 15 and 5 cancel to be a 3 and a 1, respectively. 1 times 3 is 3. 1 times 4, I got 3/4.
Hey.
Good?
Yep.
Any questions?
You know it.
Okay, then number 3 and number 4. Okay, so number 3, do you guys see any distributed properties in there anywhere?
Yes.
Yes.
What number is being distributed?
Negative 5.
-5, right? It's not 5 because you keep the sign in front of the number. With the number, it's -5. So as I distribute that -5, I end up with 4x minus 5x. And this is the spot where if somebody's going to mess up, this is usually where they mess up, right?
Oh, yes.
What's the next symbol? Plus. Yeah, because a negative times a negative is a positive. So plus 15, plus 1, plus 8x. And from here on out, it's basically a question of adding up like terms. So what term is like the 4x?
Negative 5x.
Yeah, there's 2 of them. So let's see. Do you guys get 7x there? And then, 15 plus 1, those are both like terms. So plus 16, 7x plus 16. All right, and then number 4 was the one that we have struggled with the most. It's our concept that is kind of the lowest on the mastery scale. So when you guys see the words 9 more than, what does that mean? Plus 9. Yeah, we're going to add 9 to something. So I'll just put plus 9. What am I going to add 9 to? A quotient. Yeah. Quotient of x and 5. Quotient is division. I agree. And so x and 5 on division would be x over 5. The order matters there. And then this phrase right here is at most. What does that mean?
One of those signs. It's
Less than or equal to.
yeah, that.
Think about it. If I'm telling you the biggest something could be, it could only be that thing or less than it, right? Yeah?
Yes.
If I told you that my height is at most 6 feet tall, that means if I told you I was 6'5", that would be outside of the realm of 6 feet at most, right?
So false.
And it would be false also. Yep. Okay. And of course 13 goes there. Any questions? We all good? So when you see this tomorrow on your DMR quiz, you're going to be like, easy, 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 got it. I hope so. I hope so.
Easy, squeezy.
Okay. So as I mentioned before, today's class is going to finish with Concept Quiz 4, which is simplifying algebraic expressions. But leading up to that, we're going to go ahead and look at Unit 2, Day 1. So if you'd flip over, we're going to look at our class examples. And this unit, as I mentioned before, is about everything linear. Linear equations, graphing lines, writing linear equations, all those things right there. And so we're going to do some examples here. So this, sometimes for some folks, I hope you're listening, this is where sometimes there are some moments of frustration, maybe some pain, and it revolves around showing your process. So here in math, here in algebra, I am definitely interested in you getting a correct answer. There's no doubt about that. But I am at least as interested in making sure that you understand why that's the right answer and how you got there versus, oh, I got a right answer. Just don't worry about all the other stuff. I will worry about all the other stuff. Okay? So I want to give you some good examples of how you would do this. So first of all, let's talk about the word solve. And I want you to think about this for a second. Solve. We haven't used that word once this entire semester until now. I have not used that word, I don't think, ever. So solving. We can solve equations, but so far all we've done is we've evaluated stuff and we've simplified stuff. We haven't solved a thing yet, but we're about to. So when you see the word solve, what solve means is find the number, or perhaps numbers, that makes the equation true. Find the number or numbers that makes the equation true. find the numbers or number that makes the equation true. There's another kind of a classic interpretation of the word solve. Like maybe your middle school teachers taught you this. I don't know. If it says like solve for x, what does that mean?
Find X.
Okay, find x. Maybe use a different word.
The variable.
Get the x
Alone.
by itself, alone. There you go. Yeah. So you could think of this solve. You could also think of this as get the n by itself on one side of the equation. We're going to have to do some algebra to get it that way. Exactly. So guys, these are two classic meanings of the word solve. Find the solutions that make the equation true, or get the variable all by itself. These are two classic ways to look at it. We're going to talk about how you do that and then how you check your answers. So if I look at a question like number 1, it says solve, and it says 14n equals 154. This is where all those properties that you put on your posters will come back to help you. How is the 14 attached to the n? Because the n is not by itself, right? It's attached by multiplication. What is the inverse of multiplication? Division. So the way that I get rid of the 14, and here's what I want you to show. I hope that you're paying attention because I will definitely be looking for this. I want you to show that you have divided both sides, not one side, but I want to see that you have divided both sides by the appropriate number. In this case, it's 14. When you do that, the 14 cancels with the other 14. You end up with n is equal to 154 divided by 14. Off the top of your head, you know what that is?
11.
It's 11. Yay.
Well, actually, I just did long division.
So this is a pretty simplistic equation, but here's how you check. If I get this answer here and I say, you know what, I'm pretty confident that n equals 11 is the solution. This is the number that makes the equation true. The way you check it, Kyrie, is?
You plug it back in.
That's right. You plug it back into the original. So you would say 14 times 11 is equal to 154. You evaluate this and see if it really is true. You do a little work off to the side, do some multiplying, whatever it is, and you find out that, yes, 154 really does equal 154. It did check out. 14 times 11 is 154. And so you would say that it checks, and you could say confidently that n equals 11 is the solution to this equation. Make sense? So you guys should be writing this down with me. I know you're at a little disadvantage because you don't have the notes packet, but regardless, make sure you're writing it down. Does it make sense? I'm trying to get you to get the concept of what we're doing. Okay, number 2 says solve. This one's a little more complicated, right? Because you ask yourself, is the x all by itself? And obviously the answer is no. There's not one thing with the x. There are two things with the x. And so what I need to do is get rid of the minus 2 and get rid of the 3, right? There's two things there with it. And the order in which you get rid of them is either going to make this easier or harder to accomplish. I would say in this case, I would like to get rid of the fraction before I do anything else. I mean, the fraction makes me just a little uncomfortable. And obviously it's, something divided by 3. So again, back to the properties. What's the inverse of divided by 3? Multiply. Isn't multiplication the inverse of division?
So true.
So what we're going to do is we are going to multiply by 3. What I'm going to do is multiply the left side by 3. And I'll multiply the right side by 3. So get rid of that fraction. And maybe you put 3 over 1. I don't know. So on the left side, do you see that when you multiply by 3, do you see how the 3's just cross-cancel right out? That's the whole point, right? We wanted to get rid of the fraction. So the 3's cancel. So I end up with x minus 2 equals 36. 12 times 3 is 36. Then finally I have to get rid of the minus 2. Well, what is the inverse of minus 2? Plus 2. So I'm going to add 2 to both sides. And when I add 2 to both sides, I get x is equal to 38. We'll check that here in a second.
Whoa, I never was able to do it.
Shh. Hey guys, let's not be a distraction, please. Thank you. So have you noticed that with numbers 1 and 2, in every case I've said, let's divide both sides by 14. Let's multiply both sides by 3. Have you guys ever heard of an equation, like kind of a representation of an equation, almost like a balancing act? Right, so you have this nice balanced equation. So if you decide to add 2 to one side, now we're out of balance, right? But if you add 2 to both sides, now we're balanced. So in other words, whatever you do to one side of the equation to keep it balanced, you have to do the same thing to the other side. It's ringing true from maybe some of your pre-algebra stuff? Okay. All right, so then how do we check this? I'm going to take that 38 and plug it in where the x was. So it would look like this. 38 minus 2 over 3 equals 12. If I follow order of operations, wouldn't I do 38 minus 2 first? So that would be 36. And 36 divided by 3 is 12. So 12 equals 12. It does check. Remember, the solution we come up with really needs to make the equation true. Questions? Okay, so let me get some suggestions from you guys here for number 3. We've got a couple more here on this page, and I'm going to turn you loose. You can clearly see in number 3 that the x is not by itself. There is a 6 right there, and there is an 11 right there. We've got to get rid of them. Any suggestions on which one we should get rid of first? What do you think? The plus 11, yes. Plus 11. So how would I get rid of plus 11? Minus 11, and you got to do that to both sides, right? Okay, so when I do that, the result is 6x. The 11's add out to be 0. That was the whole point there. 13 minus 11 is 2. So the x is still not by itself yet. There's obviously that 6 right there. How's the 6 attached to the x? And so to get rid of it, I divide. Divide both sides by 6. Divide both sides by 6. So then the 6's cancel out. 2/6 reduces down to be 1/3. Right. Okay, so that's my proposed solution. How do I check? I plug it back in. So that's what my check will be over here. I'm going to say 6 times 1/3 plus 11, hopefully equals 13. What's 6 times 1/3? 2. Yeah, it's 6 over 3 essentially. And 2 plus 11, look at that. That really is 13. It checks out. We can be pretty confident we didn't make any mistakes. Okay. Any questions at all from anybody? Yes, sir.
Can't there be multiple answers?
So for a linear equation like this, there's only one answer. When we look at an linear inequality like we're about to in number 4, there are multiple answers. If you look at a quadratic or did you do parabolas or anything like that in middle school? Those potentially have more than one answer. So yeah, there are other equations. These are just linear, so they'll have one. Okay. Any else? Any other questions? That was good. Okay. So let's finish out with number 4 here. So number 4 kind of goes to what I was mentioning there to wit. Notice how in numbers 1, 2, and 3, it was blah, blah, blah equals something. So this is not blah, blah, blah equals something. This is x plus 9 is less than 7. So this is what we call an inequality. So this is not an equation. It's an inequation, right? It's not equal. It's clearly less than is the symbol there. But we follow many of the same rules. We still want to get the x by itself. So what would you guys say? Clearly there's a plus 9 with the x. So we subtract 9. That's right. So I'm going to go minus 9 from both sides. This gives me x is less than negative 2. So this is what kind of brings up an important point. X has to be less than negative 2. Well, how many numbers are there that are less than negative 2? There's a lot, right? All of them less than negative 2. There's an infinite number of numbers there. So often we'll use a graph to help us represent this, like a little arrow and an open circle, closed circle. I don't know if you've ever done that. Here's how this works. If I'm going to graph this, I am going to put an open circle on negative 2. I'll just put it right above. Negative 2 obviously being the key number. We found that that's kind of our key point with our solutions. And I want numbers that are less than negative 2. So I'm going to draw an arrow which direction? To the left. Yeah, because all the numbers that are less than negative 2, they're over there. So x is less than negative 2. Why the open circle? Is that your question?
Yeah.
Yes. Why the open circle? So what the open circle means is this. It means up to, but not including, negative 2. So it goes right up to negative 2, but it doesn't actually include negative 2. Because we want everything that's less than negative 2, we can't include it, right? But if this symbol, and I think you'll maybe see this coming up in your in your practice questions, if this symbol right here was less than or equal to, then what we would do is we would actually fill this in and make it a solid or a filled in circle, okay? But this one needs to be open. Great question. We'll do a lot of these over the next 4 days. We'll get in a lot of good examples of both equations and inequalities. So how do you check this one? It's a little bit weird because there's not just any one number that works here. If you were to try any number on this interval over here, if you tried any number like -4, -7, -10, any of those numbers should work. So let's just pick one. What do you want to try?
-7.
-3, -7, sure, those are all good. So if I checked it, I'll just do this off to the side. If I said -3 plus 9 is less than 7, this is 6, and is 6 really less than 7? Yes, it is. If I tried -7, I'd get -7 plus 9 is less than 7, so that would be 2 is less than 7, also true, right? So any numbers you try on the left side of that open circle should work out just fine. They should check. There's one last thing here that your book puts in, and I probably normally wouldn't put this into an Algebra 1 class, except all of the WebAssigns ask for this. So I want to help you so that you can be able to do your WebAssign. This is a little more of an advanced thing. I normally wouldn't probably expect you'd see this until Algebra 2 or something like that. It's this interval notation stuff over here. And here's how this works. It's just an advanced notation. And here's what it would look like. We have an open circle on -2, and then we're going all the way to the left. And if we just keep going to the left, aren't we heading towards negative infinity? So this interval notation is kind of funky. Please don't stress about this right now. I just want to show you so you can maybe do your WebAssign. What you do is you'd put a parenthesis, like a rounded parenthesis, negative infinity, comma, -2, and then a rounded parentheses. All that means, that's just representing this. It's saying that I know there's all this y stuff. It's just a different notation. I didn't make it up, so don't get stressed at me. If you look at your book, it's all in there. And it's in a lot of math books. So all that means is that all of your answers stretch from negative infinity to -2. So it's just a different representation of the graph. If the WebAssigns all didn't have that and require you to have that, I probably wouldn't teach it. But I want you to be able to do your WebAssigns. Does that make sense?
Yeah.
We'll practice it some more as we go. So if you guys would, flip over and let's do your practice questions. I'll show you these up here as well. Right here. I can fit a couple of these in. So there's 1, 2, and 3. There's a fourth. There we go. Yes, ma'am. Sure. Hurry back, though, because you need to practice this. What's that?
Nothing.
Okay. That's fine. So number 1, this is really similar to number 2, I think it was. Do you guys see how the whole left side of the equation is a fraction? And so, or you could say the whole left side is divided by -5. Because of that, I want to get rid of that fraction before I do anything else. So what I'm going to do is I'm going to multiply both sides by -5. The reasoning for that is multiplication undoes division. So I'm going to multiply the left side by -5. I'm going to multiply the right side by -5. -7 times -5 is positive 35, and over here the -5s would cancel out. That was the whole reason for doing that. Lastly, I've got to get rid of the plus 1. How do you get rid of plus 1? Subtract 1 from both sides. So when I do that, I get x is equal to 34. So I believe that is the correct answer. The way you check that is you plug back in. So it would look like this: 34 plus 1 divided by -5 is equal to -7. 34 plus 1 is 35. And 35 divided by -5 really is -7, so it does check out quite nicely. Any questions on number 1? Okay, then number 2, 5x plus 6 is equal to 1. I've got to get rid of the 5 and the 6, right? Any suggestions? Which one do I get rid of first? The 6. And how would I get rid of that plus 6? So if I subtract 6 from both sides, I get 5x equals -5. And then what do I do? Divide both sides by 5. And so I get x is equal to -1. And if I check, I've got 5 times -1 plus 6 equals 1. I'm just plugging back in to check. This is -5 plus 6. And that is 1. 1 equals 1. It does check just fine. Where do we stand with number 3? Looking around, I saw a decent number finished. Are we ready to do 3?
No.
Okay, let me just give you another moment here to do number 3. And if you did 3, and some of you, like Ben, are sitting here all confident, number 4, he has not done interval notation yet. I'm seeing a lot of folks that have not. Will you please try the interval notation? Similar to what we did on the previous page. Give it a shot while I'll let you finish up with 3 and 4.
And then once you solve the problem, I'll help you finish.
There's 2 different ways you can do this. You've got 2/3 x is equal to 14. So as I walked around, I had a lot of people say, hey, could I multiply by 3? Because we've kind of done stuff like that already, and that's a perfectly good idea. So if you multiply both sides by 3, then you get the 3's canceling out, and you get 2x is equal to, and then 14 times 3 is 42. How would I then get rid of the 2? Divide by 2, and you get x is equal to 21. Say again?
Or you can multiply by the reciprocal.
So that's the other way. There is a faster way, and this is the principle. If you remember from back in the properties video, I think I called it the multiplicative inverse or the reciprocal. Hey guys, you good?
Yeah.
I'm just having a hard time talking over you. If you want to talk, that's cool. Just whisper, okay? Or talk a little quieter. Thank you. I think I called it the reciprocal property, the multiplicative inverse property, something along those lines. And it's what you just suggested, Ava. If you want to get rid of a fraction, then all you have to do is multiply by its reciprocal. So let me illustrate that real quick. If you've got 2/3 x is equal to 14, then if I multiply both sides by 3/2, so if I multiply by the reciprocal on both sides, here's what happens. Wouldn't the 2's just cancel out right away? And the 3's also cancel out?
Yeah.
So then over here you get x is equal to 14 times 3/2, or you can say 14/1 times 3/2. That gets us to 42/2, and that also reduces down to be 21, just like the other answer.
Cancel 14 and
Yeah, 14 and 2. Yeah, you could have canceled it right here and gotten 7 and 1. That would have worked too. Yep. Okay, you can check it by plugging in, but I want to get to this last one, number 4. So in number 4, it's an inequality again, right? It's not the equation anymore. This is what we finished with on the first little set. We got to get rid of the 5 and also the -7. Which one would we get rid of first?
7.
The -7. How do you get rid of -7?
How do you add 7?
Yep, you got to add 7 to both sides. This gives us 5x is greater than or equal to 20. And then to finish this, I would,
Divide by 5.
right, because it's 5 times x. To get rid of times, I divide. So dividing by 5, I would then get x is greater than or equal to 4.
Severely wrong.
So what I'm going to do here is I'm going to put in a filled-in circle on the 4 because it includes the 4 because of the or equal to part. And then I want numbers that are bigger than or equal to 4, so my arrow goes which direction?
To the right.
To the right. That is correct. So all those numbers up there, 4, 5, 6, 7, 8, 9, 10, ... those should all work. Here's how you do the interval notation. Question, Ben, first?
I thought when you divide, then you guys switch the sign.
It's only if you divide by a negative or multiply by a negative. We'll get to those in the next couple days.
Yeah, okay.
Good memory, though, for sure. Here's how you would write this interval notation. Aren't we heading towards positive infinity on the right edge of the graph? So what I'm going to put here is 4, comma, infinity. And I'm going to put a round parentheses on the infinity. But I'm going to put a sharp-edged bracket on the 4. The sharp-edged bracket stands for it includes the 4. Right? So the sharp-edged bracket would go along with the filled-in circle.
So the other one was just a normal parenthesis because it didn't include the thing.
That's exactly right.
You got it.
Exactly right.
You got it, mate.
Any other questions? Well, guys, listen, I don't expect you to have this perfectly mastered right here. Maybe you're doing pretty well, and that's awesome. But even the interval notation thing, I don't expect you to be a master of it immediately. We're going to spend like the next 4 or 5 days on this. So just know you'll get a lot of chances to practice and hopefully get better and better as we go. Okay? Cool. If there are no other questions, I think that's it for Unit 2, Day 1. Mariah, your question? Hold on. Did I do what? Don't erase it? Oh, yeah, for sure. Yep. Okay, we are going to do your concept quiz 4. So if you guys would rearrange your tables so all face the front. And we'll grab the little dividers. We'll get started with that.